Alright, we want to look at some constraints when we have ropes and pulleys. So if we have some pulley and we have some amount of rope here that's going over our pulley and down this side, and then we have some object attached to our pulley, and our pulley has some radius r. The condition is that our rope moves over the pulley without slipping. And if our rope does that, and we think about some point on the rope here, and then the rope's point, as the rope comes up, goes over and exits, the rope covers, some radial distance s here. Well, that radial distance that it covers is the same distance, from here to here as this object. Let's say our object moves from here down to here. This distance s has to be the same as this distance s. That when the object is moving, we know that this distance s has to be covered in the same time as this distance s. And we know that the speed that this wheel rotates from, point here to point there, we know that the velocity of our wheel is r omega. It's whatever the rotation speed is times the r. And because the rope lies on the rim of the wheel, this is essentially the r of the wheel. And this velocity, r omega, that has to be the same velocity of the object. So the velocity of our object has to be r omega if it's going over a pulley. Because in order for this amount of rope to come off the pulley, the object has to move that same amount of distance in the same amount of time. And now it turns out that if the pulley starts accelerating, then by the same logic, the acceleration of the object has to be r alpha. Whatever the angular acceleration of the wheel is, that much rope has to be coming on and off the wheel because our rope moves without slipping. So whatever this curved distance is x, this arc path that the rope travels, there it has to travel here. And so our condition for our ropes moving over pulleys is that the acceleration and velocity of the object have to be either r alpha or r omega, depending on if our object is accelerating or not. So this is our condition. Our ropes move over pulleys without slipping. Velocity was equal to r omega, and a tan was equal to r alpha. That means our object here has to have the same speeds and accelerations that the pulley has if the rope moves without slipping.